Question 16 is talking about a standing wave. It says it's a third harmonic, so that means it has 3 antinodes if it's fixed at both ends. So it's fixed, fixed, and then we have 2 more nodes. Sorry, they aren't perfectly equidistant. Something along the lines of that. So we have a wavelength of 0.80. So the wavelength is 0.80, and we're looking at 2 points on the wave that are 0.06 apart. So let's take that node and this point here. What is a possible phase difference between the 2 points on the wave? Now, phase difference on a standing wave is not the same thing as on a progressive wave, so a wave that is passing through time, passing through space, I beg your pardon. So when we've got a standing wave, the points here, any points on this part of the wave, are all in phase with each other. In other words, they are moving and will meet their maximum displacement at the same time. Okay, so for example, as the wave moves upwards along here, every point on the wave at this point, here, 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 and here, they will all reach their maximum, their own maximum amplitude displacement at the same point, okay, in time, at the same time, which means they are in phase. However, when you move to the next section of the wave, they are 180 degrees out of phase with the previous section. So this is pi out of phase with the first section, but all of these points are in phase. And then for the final section, or the next section, and so on, these parts are all in phase, and again they're an additional pi out of phase with the red section. So in other words, 2 pi out of phase, or back again in phase with the initial section. So what is the answer? This section and this section are pi rad out of phase. 17 is testing your knowledge on refraction and reflection. So you must remember, for refraction to occur, we need to be going from a less dense to a more dense. Okay, it won't work the other way around. Okay, we get total internal reflection. So for refraction to occur, it's less to more. For total internal reflection, we're going more to less. Okay. So it could be more to less. It could be A. Oh, sorry, it's not working. Okay. It could be B, but then again, it can't be, because we're greater than the critical angle, which means that there's no refraction. So it's not B. It can't be C, because it looks like we've got total internal reflection here, but we're going less to more, and that doesn't work. So it's not C. And again, same idea here. It's not D. The only one it could be is A. For 18, it's asking for the relationship between intensity and amplitude. Now, in the data booklet, we have intensity is proportional to amplitude squared. So it says two identical waves, each with amplitude x0, interfere constructively. Okay, so let's draw it out. We've got an initial wave like that, with amplitude x0, and then we've got a second wave which is the same. Let's dot over it with red, and also has x0. So if they're interfering constructively, it means the resultant wave is going to look like this, and it's going to be 2x0. So it's one of these. Now, intensity is proportional to amplitude squared. So the intensity is proportional to 2 squared x0. So it's proportional to 4x0. So it's 4ID. Question 19 is about polarization. We've got two polarizers, and the light is passing through the first one and then through the second one, which is at an angle. The second polarizer can be rotated to vary the intensity of the emergent light. What is the maximum value of the intensity emerging from the second polarizer? Okay, so if we start off with intensity 1, coming through the first polarizer, only the light plane, the plane of the incident light that is in parallel with the plane of the polarizer can get through. The other plane is stripped, so we get I1 over 2. We get half of the light coming through. But if we were to move this second polarizer so that it's in line with the first one, like that, effectively, in theory, it still goes through. Okay, so we've got the light coming through like this. This is very hard to draw, okay. This one carries on through, and then it would still carry on through like that. So we would still end up with I1 over 2, okay, in theory. And then finally, question 20, which of these waves cannot be polarized? Well, only transverse. Okay, transverse can be polarized. So microwaves, electromagnetic, can be. Ultrasound, sound is longitudinal. That's not looking promising. Sorry, I'm just going to rearrange my screen a second. Ultraviolet, electromagnetic. X-rays, electromagnetic. Okay, so it's B. Ultrasound cannot be polarized